today's lesson, we are going to discuss dimension analysis, how we can calculate the dimension analysis given different formulas of different quantities. So what is a dimensional analysis, or rather what is dimension analysis in general? Well, dimensional analysis is simply a technique used in physics and engineering to analyze the dimensions of physical quantities and their relationships. So this is used on the principle that all physical quantities can be expressed in terms of a set of fundamental dimensions, such as length, which of course is represented by capital letter L, mass, which of course is represented by capital letter M, time, which of course is represented by capital letter T. Okay, we also have some other quantities such as electric current, which is represented by capital letter I. We also have temperature, which is represented by theta, and finally we have the amount of substance, of course, which is the mole, represented by capital letter N. So dimension analysis, for us to answer these questions, we have to master these symbols. We have to know the symbols used for different physical quantities. So for length, we know it's L. For mass, we know it's capital letter M. For time, we know it's capital letter T. For electric current, I. For the, of course, temperature, is theta, and finally for the amount of substance, N. So these are the letters that are used for different dimension analysis physical quantities that we need to know and understand. So make sure that you write these symbols representing the physical quantities. Okay, so in short, this implies that the dimensions of a quantity are the base units that make it up. Generally, we use the dimension analysis using the square brackets, these. So we represent dimension analysis using this symbol. So this symbol is very important when it comes to dimension analysis. Okay, as we go on, you are going to understand different things. Moreover, it is very important that we understand and know how dimension analysis help us and what they are used for when it comes to calculations. Firstly, dimensional analysis is used to find correct units of a physical quantity in a formula that we have been given. We are going to look at this when we start looking at examples. The dimension analysis is also used to guess the correct formula when the units of the physical quantities are known. Okay, so as we go on, you are going to discover that you will be able to discuss, or you will be able to guess the correct formulas that you can use for different physical quantities. Then this is also used to check the dimensional consistency of an equation, whereby the left side of the equation is equal to the right side. Of course, if these two implies, then the dimensional analysis is correct. Okay, let's look at some of the examples. For example, we have speed. So speed, we know the formula is that speed equals to distance, of course, can be represented by either x or s according to the book that you are using. So in this case, we are going to use s, representing the distance, over time, which of course is this. So this is the formula. Moreover, when we are dealing with dimension analysis, it is also important to know the units, because sometimes it's not only the formula that is used, other times are the units that we can use. So for speed, we know that the units for speed are what? Meters per second, right? Where meters represents the distance, and of course second representing time. And we know that speed, in this case, will be represented by the units, of course, which we are from discussing, saying it's what? Meters representing what? The distance, over time, okay, represented by the seconds. So now, for distance, what dimension are we going to use? We know that distance, of course, will be represented by length, okay, and length in our case was represented by what? Capital letter L. So in this case then, where there is distance, that is s, we are going to replace with this, okay, and then where there is time, of course we are going to replace with what? With this. So of course this is the dimensional analysis for what? For speed rather, in this case. Okay, so this is how we represent them. So you know the units for the given physical quantity, and then replace with the dimensions of that quantity, or of the units of that quantity. Let's look at acceleration, for example. We know that acceleration is what? Meters per second what? Squared, right? So in this case, acceleration, dimension analysis for acceleration will be meters representing the distance. And of course we know writing like this is the same as writing like this. Okay, so where there is meter, we are going to write what? Okay, dimension L, over where there is second, of course representing time, we are going to write capital letter T, and then we square this. So this is the dimensional analysis for what? For acceleration. So it's very important to understand how we replace. So basically this mostly uses the what? The units. Okay, now how can we know that the given formula is correct or is not correct? For example, is this correct? Let's say we have this formula here. I hope you have seen this formula somewhere. Moreover, it's important to take note that when you are dealing with dimension analysis, the figures are simply what? Ignored. So in this case, the figures here, that is 1/2, will simply be ignored and it shall be removed. So let's do that. So we are going to remove this and then just deal with what? The rest that we have. So all the figures in the given formula, or in the given whatever you have been given, you simply have to ignore the figures. Dimension analysis does not deal with what? With figures. So we know this is what? This is velocity. So velocity is obviously, or we know that is calculated or is measured in what? Meters per second, right? So in this case, these are the units we are going to use for this velocity. So in this case, we are going to have meters per second equals to, in fact, even this is also initial velocity, so it's meters per second, the units are the same. Okay, plus acceleration, we know the units is what? Meters per second what? Squared. And then here we are multiplying with what? With time. Of course it's represented by the seconds. Now let's write the dimensions for this. So we know that meters are represented by which dimension? Dimension L, capital letter L, over this second here is time, and we know that time is represented by capital letter T. Okay, so this equals to, where there is also M here, we are going to replace with what? With capital letter L. Okay, over time, which of course is T in this case, it's gonna be that. Then we add here, where there is meters here, we are going to replace the same as we have replaced before, and where there is of course time represented by second, it's gonna be replaced with capital letter T, and then we are multiplying this with what? With time, of course, which is the second in this case. So we are going to have capital letter T this side. Okay, so let's simplify that. Now before we do that, let's wrap the top part here so that we can have the space. Okay, hopefully that you are following. Now we are going to rewrite the left side. Okay, we don't have what to simplify on this side, so we are just simply going to have that equals to, okay, we have that over, okay, we have this, then plus, in this case we have this here, and we know that these are twice here. Now if we divide this into that, we are just going to remain with one dimension analysis for T, which of course will be that. So in this case then we are going to have this, okay, over that. So if we can see throughout in here, we have the same things, right? So this is dimensionally correct, okay, because we have all of these similar here, but it's not dimensionally equal because this is once the twice of this side here, because if we add this and that, we are going to have twice of this here. Okay, so I hope that you understand. So this is basically how we replace in the given formulas. Let's look at another example. Let's say we have x equals to vt squared, where x represents what? Distance or length. So we know that this is going to be replaced with what? With L, right? Okay, equals to, where there is velocity here, we know that velocity is meters per second, and meters per second is meters per second. Okay, let's just write this at this time, and then time is represented by second squared, right? Okay, so here we have this, okay, equals to, so where there is m, it's the meters representing what? The length, which is of course L, and then second is time. Okay, so we have that, so multiplied by time squared. Okay, now we know that this is going to be divided in there, so here on top we are simply going to mean with 1 here, right? Okay, so in this case, let's just wrap this top part here, it's not necessary for us. Okay, we have that. So in this case then we are remaining with L. Okay, let's replace L equals to, okay, here we have L as well, okay, multiplied by, here we are remaining with what? With T. Okay, so in this case, if you don't want to write like that, if you want, you can just end it up to here. It's a very correct leaving it up to here. Okay, or you can go further where you have this, okay, and then this. Okay, so this is the end of this question. Now, is this dimensionally correct? Okay, of course, as we can see, the right side here is different from the left side, so this is of course different. So since this is different, this is not dimensionally correct. So basically you have an insight on how we manipulate questions, or how we use the dimension analysis to find out if the given formula is correct or is not.